Hey, Jim Bergman here with measureQuick. It's getting to be fall and getting a couple questions about how to use some of the gas heating section stuff, so I wanted to go over some of that. I've got this set up. I've got some Testo Smart probes. I got a return, and I've got up here a supply air temperature. I've got over here 4 manometers, so I've got one that's reading the supply static, one is reading my incoming gas pressure. I've got a clip here set up, so I'm on a basically just clip this off so I can measure my induced draft pressure when I get ready to do that. And then I've got my manifold pressure here. So I got 4 different manometers, and I like getting everything set up like this so I can do a test pretty quickly. It's mild here right now. I don't want to run the furnace for 4 hours doing a quick test on there. Also, I got my combustion analyzer zeroed out, and we're pretty much ready to roll at this point. So I'm going to go in my results tab because I've done my furnace before, and I'm going to go ahead and just set this project as active. And now I'll go into the project, and you'll see that my project, my job site information, my equipment stuff's already all done. So I go into the project details. You can see I marked it. My external static pressure was high when I did that. Job site information, I got the house marked. I've got the address all in and all ready to go. And then if I go back to my equipment information, you can see I've got my models and serial numbers already put in here. So very, very quick now because I don't have to collect all this new data again. So this is all older data here. And then I can get my electrical information, and all that's pre-filled out. So I'm going to go ahead and just do a couple things I just want to demonstrate on the test. So once we're in a project, you're going to get down to the bottom, you're going to get that project with the exclamation button on there. And I can pretty much start anywhere, but the way we have this set up is, first of all, you enter your information. So again, I used the project from last year, so it's 90 plus natural gas condensing. I got the furnace, it's a full modulation furnace, but I got it on high fire. So everything's pretty much ready to go. So I can open up and hit my temperatures and pressures. I can see my supply, my return, my temperature rise. You notice I don't have any airflow yet, and that's because I haven't gone through and clocked my meter. If I go ahead and go to my CO reading, I did do an ambient CO test, so I'll go ahead and hit 0 on there. I do have, and I'll show you this here, this is a gas leak detector. This is by far one of the best gas leak detectors out there. It's made by AccuTools. You turn it on, it does have about a 15-second warm-up time. It's a combustible gas detector, so it detects any combustible gases, propane, natural gas, whatever you're using on here. A lot of times you'll find gas valves leaking through, so I'll test up in the burners when the furnace is off, and I'll test around my unions and joints and things like that. And that's my gas leak test. Now I already went through my whole gas line and tested this, so let this finish warming up here and I'll just show you how it works. But once it starts up, it beeps and it starts on the high sensitivity mode, and all we do is just slowly move this around at about a quarter inch per second, and just sniff the gas lines and make sure there's nothing leaking on here. If you do come across the leak here, it'll go to a real high pitch real fast, which I may be able to pick one up off my incoming gas here. Well, nothing's leaking here. So yeah, right there's on my manifold. I just threaded it in by hand. It'll pick that up, and then you can use like a snoop or an under leak detector to do that. If you don't have a combustible gas detector, you should highly consider getting one, because this is a money maker. This is about finding leaks in gas lines and being able to make those repairs. So very, very handy tool to have to make sure that we're getting that part done. So I've got my gas inspection done, visual inspection on these. Realistically, I'm just looking at the flames and making sure my flames look good. There's nothing abnormal in there. Everything on that looks good. Also looking for evidence of water leakage down in the bottom of the furnace here anywhere. Condensate leaks on 90 pluses are very common, so you want to make sure there's nothing there. So I've got the visual inspection done, the gas leak detection done. And then I can go into my, my temperatures. I have my supply and return air dry bulb. Now before I typically take these, what I do is go into my trending, and I'll start looking at my supply air temp and return air temp. You can see my return air temp is rising. That's because I'm running the furnace, right? And that's going to happen. And my supply air temp, and I'm looking for these things to sort of stabilize out. This has been running for a few minutes, so you can see it's starting to flatten out on there. So, pretty much we reached what we call steady state at this point. I can capture those temps if I want to, or I can just leave them run. Right now, I'm just going to leave them run. I have about a 62 degree rise, 63 degree rise across my heat exchanger. So if I go back here, I go to trending again, I can probably look at the temperature rise. We'll see here if that's on this. Apply and return. No, we don't have temperature rise on the trending by itself. I'll probably have the guys do that for us. So temperatures are good. Pressures right now, I can see my inlet pressure is 6.93. So I'll go ahead and capture some of my inlets. My return air static, my supply air static. You can see my total external static at 1.32 is really high. I did switch to a media filter and it's probably a little bit dirty here. I'll capture that reading and I'll hit submit. And I can move these around too. So let me show you this. Let me go back into the pressures again here for just a second. So you can see my induced draft pressure right now is a field input box on there. So what I'm going to do is, now that I have my static pressure done, I'm just going to remove my supply static manometer, and I'm just going to go in here, go to toolbox, and my supply static here, I'm just going to remap it to induced draft pressure. Go back to home or project here. I'll go back to home, go back to pressures, and now you can see my induced draft pressure is 0.08, just the manometer, just a little drift on there. Now what I did here is I have a clip, so I can put this on here, and I'll put it on the negative port because it's drawing the negative draft. Then I can open this up and I can read my induced draft pressure on here, 1.97, and I can capture that. So this clip just allows me to remove the manometers and things like that without shutting off the furnace, right? So it just makes it a whole heck of a lot easier to move things around. And I'll use these clips. They're just binder clips. I'll use them on, on my inlet pressures, outlet pressures. So if you have one manometer, you can hook up all your tubes and then clip them all off so you got them all ready to go, and then move the manometer around and just remap it. Makes it really easy to do. All right. So let's go in here to capture the pressure. Now, this is when we get a lot on how do you use this feature on the meter. So the first thing I'm going to do is I'm going to capture the pressure. It's currently at 3.75 inches. And now I'm going to go ahead and clock the meter. So we're going to go outside here. Notice my heat content is in at 1050 BTUs. I already profiled this, so I have 90,000 BTUs here. We're going to go outside, we're going to clock the meter, we'll make sure the input's correct. So I'll be right back. All right, so we're going to watch the half cubic foot down. I'm going to wait till it gets up to the top here. And I'm going to go ahead and hit start right now. And we're going to let that go around 2 times. I have this set for meter dial, half foot, 2 revolutions on there. And we're going to let it go around 2 times, and then we'll get a clock input on here. I set this up last year, so the meter should not drift, or the gas pressure should not drift, so it should still be pretty spot on. That's the first one. And we're coming around for the second one. The reason you let it go around 2 times is so that we make sure that we're getting an accurate reading. So it sort of averages those 2 readings out here, and it's coming around to the top and mark. So we're at 39 seconds. We're at 96,100 BTUs of input. I can submit that, or I can reset it. So I'm going to clock it one more time because I'm curious if it's going to clock the same, because I know I had the gas pressure closer than that. These bifocals will make it hard to see the meter. Let me pull these down. Maybe I'll get a better reading. Start. We'll let it go around 2 times again. You got to make sure too the appliance is on high fire, which this one is right now. I have the doors open in the house so I can make sure it doesn't shut off or go into modulation. And then you also want to make sure you don't have any other appliances operating. So I've made sure I don't. So there's the first sweep right there. And we're coming around 3/4 of the way here to go, and we'll get around the top and we'll go back there. We also have, if it's really excessive fire, it'll actually tell you that you probably have another appliance that's operating on here. So we're getting the top, mark. All right, so 94,000, we'll hit submit on here. So the target manifold pressure now is 3.39 inches. So my input is a little bit high. So let's go ahead and we'll dial that back down. All right, so this is probably one of my favorite things we did in the app. After I pull out the, just got to make sure I get the right Allen wrench here. I'm thinking it's a small one here. Is just get this slid in here. Yeah, that bites. So now you can see here I got my manifold pressure 3.75, and it calculated my target at 3.39. So I'm going to start slowly backing that down. And what you'll see is as we back this down, it's not only is the gas pressure changing, but so is my input changing. Right? So And I get this down to 3.38, 3.39. Now I got to go back up a little bit. I overshot it. So now there I got my inputs pretty much spot on. So target manifold pressure is 3.39. My input now is 90,152. You can see it bounces around a little bit with your pressure. That's okay. I'll capture that pressure, and now everything's set exactly where it needs to be. So we're good to go on that. Now combustion reading wise, now that I've changed the fuel pressure, I do want to make sure my combustion's good. So I'm going to very carefully remove that so I don't have that come out. And I'll go ahead and cap my my regulator screw back in here again. Tighten that up and we're all done. My combustion analyzer is already zeroed outside, so I'm going to go into combustion measurements. And I'm just going to turn my analyzer on. So let me go back here, go back, and we'll activate the analyzer. That'll connect. Go back into the project. Go back combustion readings. Now I can start the analyzer from right here. So I'd start, and the analyzer will start bringing in readings. So it's going to take a few seconds for the analyzer to stabilize out. So we're going to be looking our temperatures, our pressures, that kind of stuff. And right now our CO is about 9 parts per million. And again, we can go back and we can look at our trends. So, and this is really a good place to start looking here, is probably, let me see what we got. CO and CR free are probably where I have to look on there. CR free takes into account your carbon monoxide and your oxygen. So if we have a decrease in oxygen or an increase in CO, we'll see that. So when it first lights off, it's going to be higher, and then it's going to sort of dip down. So we'll see that sort of stabilize. This one was already running, but as it runs here, we'll see where it stabilizes out at, and then we'll get an idea of when our combustion is stable, our analyzer is stable on there. We can scroll through the readings here. You can see our supply and return air temp are really stable right now. Our manifold pressure. These gaps are because I walked out and left. If you want to clear those out, you can always restart your trends, right? And so now they're restarted. Inlet manifold pressure are really stable on there. Excess air and stack temp, O2 and CO2. And then we'll go up here to net and gross, and then back to CO and CO air free. So right now, those look like they're really nice and stable on there. So we're in a good position now. I can capture my readings. I'll give these a couple more seconds. When you start seeing a little modulating up and down, that's just the analyzer, changing slightly. And we're only talking about small parts per million here. If we look at the analyzer here, this is 22 parts per million up to 27. So these small fluctuations like this in the CO air free are just indicative of the combustion. The graphing shows that at a lot more granular level than you might expect it to. But for all intents and purposes, this thing is stable. It's just small changes in the analyzer we're picking up in there, and that's okay. So I'm going to go back to combustion here. Combustion measurements. I'm going to capture all my values. I'm going to check everything. CO is 12 parts per million. O2 looks good. Combustion air looks good. Stack temperature. If you don't know where anything's supposed to fall in a range here, let me just show you this. I'm just going to go hit the X here. I can look at my CO all on the graph. So my excess air is good. Combustion air is good. Stack temperature is good. I can swipe this over, and we'll see our manifold pressures are on. Inlet pressures are on. Induced draft pressure is good. Total external static pressure is a little on the high side. Supply air, return air are good. Temperature rise is good. Airflow is good. So everything looks good on this right now. Our efficiency net is 88. Gross is 90.2. We're not doing a lot of condensing because the return air temperature is high. Outdoor air temperature is warm. Output looks good. Our CO2 and O2 look good. And then back to stack temperature. So I'll go back to combustion measurements, capture the values, and then we'll just stop the analyzer here. So I'm going to go ahead and submit, and all those values are now locked in. So now we got to do a couple of electrical readings here. And again, I've got a Redfish 550. Now what this one won't do is the flame rod microamps, and that one we got to get a little bit differently here. But I'm going to go ahead and go back here, hit my toolbox, connect my meter. What I may have to do here is disconnect. Now you'll see right here I'm not connecting, and I'll show you why here in just a minute. I'm going to disconnect my blue flame, and I'll disconnect my my Testo Smart Probes. Give this just a second here. I'll try and connect again. What happens here is I have too many Bluetooth devices all at once because all these Testo probes are paired in, The blue flame's paired in, so that's why we made it so you can capture measurements. And now I should be able to connect, and I'm good to go there. I'll go back to the home screen, back to electrical. So now any reading I can test on there, I can test on the electrical side. So I'm going to go ahead and clamp around my incoming power here, and I'm just going to go to ground here and measure against my hot leg. Well, let me just do this way here. Get a ground and measure against my hot leg here. So I can see I got 119 coming in for incoming voltage. I'll just capture that. Now, also, because this has got a grounded secondary on here, I'm going to go ahead and grab some voltage here at the pressure switch. So it's got a grounded transformer, so now I get my incoming voltage 24.5, capture that. My polarity, I want to check for my 24 volts to my hot, so I'm going to go ahead and tuck this up in here so I can get a reading there, and then touch my hot leg. That should be about 96 volts. What I'm testing is from hot 120 to 24, and it should get 96 volts for polarity, so that's good on there. Hit capture, and now when I turn the meter to amps, so I'll turn this to amps, what you're going to see is that now the combustion blower amps can be measured. So I'll just clamp this around, get my combustion blower amps at 0.9, so we'll hit capture on that. And then the indoor fan, I'm just going to measure the total amps of the appliance, 7.30. This one's hard to get into the bottom, but you can grab that. So this will give us, it'll give us a fan efficacy, which is going to be low on this a little bit. If we want to grab power factor, and this is really no need to. We could get wattage. So if I want to turn this to kW, and then we'll just grab one side of this here, and we'll grab a hot. So now I got 715 watts, and I can hit capture on my indoor fan and get the wattage on there. So I've got all my electrical readings in now, and pretty well good to go. So now I can go here, save a snapshot, hit view, and share, export as PDF, and you can see we got the whole test pretty much done here. So we've got our manifold pressure, our input looks good. Any notes I put in there, model numbers, the serial numbers, and you can see this literally took me a few minutes to do to get a whole furnace test done, and make sure everything's on the money. So we're good to go. The only thing I might do here is change my filter, see how my total external static pressure looks, but hopefully get an idea how I use multiple manometers, move this stuff around, and make everything work. When we're done here, I'll put another plug in my stack here, but otherwise this thing's ready to go. So I'm going to go up and turn it off and clean everything up. This is Jim Bergman with measureQuick. Thanks a lot for watching. All right, so to measure microamps, you do have to have the Redfish IDVM 510, and this will allow us to capture that. So I'm going to go ahead and turn the meter on. I have not put this in my toolbox. We made this really cool add button on here, so I can add a meter in quickly rather than scan for it. So I'm just going to add 510, and it'll pick it up right away. I'll just hit save, go back, and connect to it. And now I've got this set up here. It's set up for microamps AC, so I'm going to hit the function key and go to microamps DC, and then we'll go back to our electrical section here. We'll go home and electrical. So now you can see the flame rod microamps are there, and I'm going to go ahead. One of the things you got to watch on this is you do have to have this on common, and you have to have it on microamps. Very, very important. And do not make the mistake of measuring voltage across this after you set it to microamps, or you'll blow your fuse internally in the meter. So I'm going to go ahead and strap this up here for just a second, and I'm going to disconnect the wire from the flame rod. And when I do that, my burner is going to go out. So I'm going to go ahead and connect one end of my meter in here, and I'm going to connect the other end on my center terminal of my flame rod here, and as soon as this reading lights here, we'll be able to capture that reading. So we couldn't get all the meter readings into one meter. It was just impossible, so we had to have two on here to do this. You can obviously always manually input a reading on here, but I prefer to capture them just so we get them all. And this is just going to take a few seconds for it to reset, because it's going to run till the blower cools down, and we'll get the reading. So as soon as it comes back on, we'll come right back to this. All right, so the furnace is coming back on now, and what I've got is the meter hooked in series with a flame rod. So a microamp measurement is literally what it is thousandths of an amp. So what we're going to do is we have the meter hooked in series, So we're just going from the flame rod through the meter and back out the other side. And as soon as the burner lights, we'll be able to get a flame signal on here, and we'll go ahead and capture that reading. So you need to make sure that you got everything held on tight, because if you don't, you're not going to get a good reading, and the burner will just shut off again. We'll hear it go through its spark ignition here in just a second. Going through a little post-purge here, pre-purge, so it takes a few seconds for it to go. Holy cow. There we go. All right, so we got our flame current at negative 2.6 microamps. So we'll go ahead and hit capture. And it's just, the only reason it's negative is because I got the meter apparently backwards what it wants. Doesn't matter whether you have a negative or positive flame signal, as long as you got it here and it's nice and stable. So go ahead and capture, and the flame rod is all set. As soon as I pull this off, it's going to go off after a second. It doesn't cut out immediately because it does give it a little bit of time. I'll reconnect the flame rod, and I'm good to go, and now I can go ahead and clean everything up. So we're all done. You want to make sure you print out a copy of the results. The great thing about measureQuick is you can print the full furnace test and not just the combustion test. A lot of municipalities, like if you get out in Massachusetts area, they require that you have a printout of the combustion results. But again, we can print the whole thing out by hitting share in measureQuick, hit print the measureQuick printer, and this thing will just spit this out pretty darn quickly. So we get a full gas furnace timestamp, we get the customer information, the system ID, all the model numbers and serial numbers, and all the readings, electrical, combustion, everything on the appliance. And then we can just tape this up and leave it with the customer, so we got a record for the year. And if you want to print a second one out and attach it to your work order, it's a lot quicker than filling out a check sheet.